Okay, inverse function part 2 video. We have another example to work with. It's f of x equal x minus 2 over 2x plus 1, and it is given defined over the interval 1, 3. So this is part 2 now. Prove that f admits an inverse function f inverse whose domain. I wrote this on purpose to know that you have to know how it admits an inverse function, whose domain and expression are to be determined. First, how to start each time. Okay? First, we should know where it is defined and continuous. If it is defined and continuous over 1, 3. Right? What is the domain of f of x? First, the denominator, since it's expression, rational expression, and we don't have any radical in the numerator or denominator, it's just polynomial. So the polynomial which is in the denominator should not equal to 0. This means x should not equal to minus half, right? So what is the domain of definition of this function? Domain of definition of this function is domain of function f is where it goes from minus infinity to minus half union from minus half to plus infinity. It's all the way in R from minus infinity to plus infinity. Just exclude the value that makes the denominator 0. So do we have a problem in 1, 3? 1, 3 belongs to this interval. 1, 3, subset of this interval, sorry. The interval 1, 3 is subset of this interval. So, is it defined over 1, 3? Yes, it's defined. It is continuous. Yes, f is also continuous over interval 1, 3. This is first thing we have to do. Domain for sure, and to see if the part of the domain we need to work with is really a part of the real domain of the function, and it should be continuous over this part. The second thing, we just directly find the derivative of this function. What is the derivative of a function rational, u over v? U over v means, u over v, I don't know if this is clear up, okay? Better than that, like that. All right, u is x minus 1. Okay, what is the derivative of function u over v first? It's u prime v minus uv prime over v squared, right? What is u prime? U prime is the derivative of the numerator, which is x minus 2. Its derivative is 1 multiplied with v, which is 2x plus 1, minus, what is the derivative of v, which is the denominator? It's 2 multiplied with the numerator, which is x minus 2 over denominator square, right? The answer will be 2x plus 1 minus 2x plus 4 over 2x plus 1 to the power 2. Okay, if we subtract 2x minus 2x, we get 5 over 2x plus 1 to the power 2, right? Now, what is this function 5 over 2x plus 1 squared? It's a strictly positive function because the denominator is strictly positive since x does not equal minus half, and it's a squaring, so it's positive. 5 is positive 2, then the function is strictly positive function. The derivative is strictly positive, sorry. This means the function f is strictly increasing function. All of the above we did, this gives us that the inverse function exists. We can find the inverse in this case, right? The inverse function, yes, it exists. Before we find the inverse function, let's find the domain and the range of the inverse. F is defined from 1 to 3. What is f of 1? F of 1 is, we substitute instead of x its value in the original f of x. F of x is given by this value, right? Is given by this value. X minus 2 over 2x plus 1. F of x, let's write it here. F of x is x minus 2 over 2x plus 1. It's x minus 2 over 2x plus 1. Yep. So f of 1 is what? Is 1 minus 2 over 2 times 1, 2 plus 1. The answer is minus 1 divided by 3. And what is f of 3, which is the end point of the interval this function defined by? It's 3 minus 2 over 2 times 3, 6 plus 1, which is equal 1 over 7. So f is a function that goes from domain 1, 3 to range negative 1, 3, 1 over 7, right? And f inverse is a function should go from negative 1, 1 over 7, which is the range of f, will be the domain of f inverse, to 1, 3, right? Let's find the expression now. Let's find the expression. This is the domain, I found it. Now we should find also the expression. It's very nice, easy. We know that f of x, which is y, equal x minus 2 over 2x plus 1. Let us interchange. What is interchange? Instead of y, we put x. And instead of x, for sure, we do put y. So the expression will be x equal y instead of yx, and instead of x, y, right? Over 2y plus 1. We do what in this case? We cross product. Why? Because I'm going to solve for y. We should find y, which is the expression of the f inverse. So 2xy plus x equal y minus 2 times 1 is y minus 2. Alright? We take y to the same side and x to the same side with the numbers. And here how we add these two, we can't. So we factorize them. 2x minus 1 equal minus x minus 2. Then y will be equal negative x negative 2 divided by the thing that is multiplied with y. So it's minus x minus 2 over 2x minus 1. You can leave it that way, or you can multiply with minus down, anything. That's fine. So what do we call this expression? It's f inverse of x, and that's it. So again, first we find the domain. First we find the domain of the function. Second, we see that the part of interval that it's defined on is a part of the domain, and for sure it will be. So we find the interval, we test the interval, and we are going to see if it is continuous, right? Then we find the derivative to see whether it is positive or negative. So the function will be either increasing or decreasing. It should be monotonic. Then after doing all that and all applied, okay, so if f inverse will exist, right, will be exist for sure, and we find it. How we find it? We interchange and we do some of this kind of work. We will see another two examples in the next video.